Ever wondered how your speakers blast music, how your phone charger steps down dangerous wall power, or how electric motors spin with so much force? Believe it or not, all of that magic comes from one humble piece of copper wire: the coil. It may just look like wire wrapped in circles, but coils are the hidden muscles of electronics, turning electricity into magnetism and magnetism back into electricity. Today, we're breaking down what coils are and how they power speakers, transformers, and so many other electronic devices you use every single day. So, what exactly is a coil? It's nothing more than a wire, wound up into loops or spirals. Simple, right? But the moment electricity flows through it, something incredible happens. It creates a magnetic field. And here's the kicker. When you loop the wire again and again, those magnetic fields stack up, becoming way stronger. Add an iron core inside, and now you've built yourself a powerful electromagnet. This is the secret that makes coils so special. They're the bridge between electricity and magnetism. Let's start with something you probably use every day: speakers. Inside every speaker is a tiny but powerful voice coil. Picture this. A lightweight coil of wire is glued to the speaker cone. That coil sits in front of a permanent magnet. When music signals, basically electrical currents that change direction thousands of times a second, flow through the coil, the magnetic field around it flips back and forth. The magnet reacts, pushing and pulling the coil. And since the coil is glued to the cone moves too, pushing the air and creating sound waves. In other words, that little copper coil is literally moving the air that hits your ears as music. Next, let's look at the transformer, the quiet hero that powers your devices. A transformer is basically two coils of wire, sitting close together, often wrapped around an iron core. The first coil, the primary, connects to the input power. The second coil, the secondary, connects to the output. Here's the magic. When AC current flows in the primary coil, it makes a changing magnetic field. That magnetic field travels through the iron core. The secondary coil feels it and generates its own current. By changing how many loops each coil has, we can change the voltage. More turns in the secondary equals higher voltage. Fewer turns equals lower voltage. That's how your bulky wall power becomes a safe 5 volts for your phone charger. All thanks to two little coils. But coils don't stop there. They're hidden everywhere. In inductors, where they filter signals and smooth out noisy currents. In motors, where they create rotating magnetic fields that spin the shaft. In generators, where moving coils through magnetic fields produces electricity. In relays, where a coil acts like a switch, magnetically pulling contacts open or closed. Whenever you see something moving, switching, or changing voltage in electronics, chances are a coil is doing the heavy lifting. So next time you listen to a song, charge your phone, or watch a fan spin, remember this. Behind the scenes, coils are silently at work. They may look like simple spirals of copper wire, but they're one of the most powerful inventions in all of electronics. They're the muscles that move, the bridges that transfer energy, and the filters that clean up our signals. From electricity to magnetism, and back again, coils are what make technology come alive. If you found this breakdown helpful, don't forget to like and subscribe, because next time, we'll explore another tiny component that secretly runs the modern world.